Hello everybody, hope you are having a fantastic day. I apologize for not making a video sooner. Life stuff happened, what can you do? Anyway, in this video I'm going to show you how to use GCC to compile C or C++ programs, as well as go over the commonly used command line options that come with GCC. If you're interested in learning C or C++ or Linux, this is, in my opinion, how you should do it. It's how I learned C and C++. And this way you are talking directly with the compiler and not some build system or IDE that is trying to abstract away those details. Build systems and IDEs have their place and certainly are useful, but I believe you should learn first invoking the compiler directly before moving on to other things. Anyways, so I have my terminal open, and in the folder that I have two programs. I have hello.c and hello.cpp. Let's take a look first of all what's in them. So it's basically, in this one is a simple hello world program as well as a variable there. The variable is not used, which is going to be important later. And the same is true for the C++ program. So it's basically the same thing, but it's written with C++ features. And I want to compile these programs to actual executable files. So generally, for C files, what you want to do is type GCC and then the name of the file, like this. And if there are no errors in your code, it will compile, it will give no output, and it will create a file called a.out. And we can run it like this. Okay, so if you want to do the same thing with the C++ file, it's not GCC, but it's actually G++. There's a difference. So if I run it with the hello.cpp file, we get the same thing, and we can run it like this. Now, you can see there's a slight difference because I didn't actually write the code, the program properly. I forget this. If you put an end L thing at the end, the new line character is not needed. Anyway, so you run it again, and here we go. So that's good. Now, I will then go over the commonly used options when you're invoking GCC or G++ directly. These options are the same for GCC and G++. So the first one I want to show you is the -o flag. -o tells the compiler to output to this file that C specifies. So for example, if you do -o hello, instead of a.out, we actually get a hello file like this. And we can run it like this. So that's that. -big O tells the compiler to optimize a certain way. So optimizing is basically after it generates assembly code. So that's what happens. It generates assembly code. After that, it will look at the code, at the assembly code, and try to optimize it to make it more optimal, so to say. It won't actually modify your source files. It's just changing the machine code instructions to be a bit more efficient, depending on what your setting is. So for example, there is OS for size optimization. So we'll try to optimize for having the smallest kind of executable. There's also OFast for optimizing for speed. Then there is O0 to O3. Now generally, I choose O2. That is the safest option. It has most of the features. O3 is a bit more extreme than O2 optimizations. So typically when you want to make an executable that is a release build, so not just a debug build, but a release version, you want O2. It's the safest kind of optimization, instead of having no optimizations. So now I'll move on to compiler warnings. If you don't know what they are, they're basically a way of telling you that you should fix your code, but not in a way that prevents you from compiling your program. So your program will still compile, but it will let you know that there's probably something you should fix about it. So if you want to enable all warnings, you can do that with W_all, like this. So this will enable all warnings, supposedly all warnings. Now you can see immediately we have a warning complaining about an unused variable. This is pretty common. If you have an unused variable and you enable W_all warnings, then you will get that warning. Now let's say we want to silence this warning, so basically get rid of this warning. We still want to have all the other warnings, but we just don't want the one for unused variables. Well, we could do that with no unused variable. See, if you look at the line with the warning, it tells you which actual warning it is. So what you do is you take that warning and then put no at the front. So it's no unused variable. So the warning is unused variable, and the warning, the way to silence it is no unused variable. So you run that, and the warning goes away. If we want to make the warning an error, if we want to make all warnings an error, we could do this, error. So if we compile it, our program does not compile, because we specified that all warnings are to be treated as errors. If we only want to specify this specific warning being an error, we can do that with error equals and then the warning, like this. Now this is the same output, but if there were other warnings, it would just be pink. In this case, it's a pink color, but here it's red, showing that it's an actual error. All right. Now we'll move on to libraries, external libraries. So let's say you want to write an X11 program. So I'll actually I'll stop the video and write a quick X11 program that uses some X11 functions. Okay, I've written my X11 program, and I actually had to install the X11 headers because I didn't have them installed on this system for some reason. Anyway, so I'll show you quickly what it looks like. So basically, we call xopenDisplay and xcloseDisplay. These functions are in X11, the X11 library. And of course, we need to include the header file for X11. So if we try to compile this, we get an error. We get two errors. We see undefined reference to xopenDisplay. So what this means is that the program is syntactically correct. It's compiled correctly, but during the linking phase, because there's a linking phase when you compile programs, during the linking phase, it could not find where the function is that we're using. So the header files tell you, oh, there's a function called xopenDisplay, but we're using it, but we don't. But the linker does not know where it is. But we have to tell GCC where it actually is. So the code for xopenDisplay is in the X11 library in the shared object file .so. The code for xopenDisplay and xcloseDisplay are in that library. So let's take a look. So on Debian systems, it's usually in userlib x86-64 Linux kernel. You can see it on the screen, and then lib x11.so. So here it is. It's a symbolic link to the actual library with the version. So what we do to link to this library, to this specific library, is we look at the file. So libx11.so. We take off the lib and we take off the .so, and it becomes X11. So this is what we pass to GCC. LX11. It's for every library like this. So you take off the lib and you take off the .so, and then you get the X11, which is what you pass to GCC. So when you run it again, it compiles properly, which means we can run it. And there's nothing here because there's no error when we call the function, because we are in an X environment. We are running the X server, so obviously it is not going to crash. If I, for example, do this, set the display to that, so this is an X11 display that doesn't exist. It says failed to open display as we expected. So it is in fact calling the X11 functions. So that's what I wanted to show you about libraries. Now, let's say you want to use a library and you don't know which one, what the library file is, like what to link it, what you use after the -l, like this. Well, it's usually a Google search, right? That's how I used to do it. I would look up undefined reference to this function, and it says, oh, you need to do like -l SDL, and then I learned, oh wait, no, it's actually linking to library. So just Google it. Usually you'll find the answer that way. So in summary, when you want to compile a C or C++ file, you use GCC or G++ respectively for C and C++ files respectively. You put the name to actually compile it. You use GCC or G++, and then the name of the file, like this. If you want to specify the output file, you do like this. If you want to set any warnings, you can use WALL to set an error for a warning. For all warnings, you could do WError, or for a specific warning, you can say WError equals and then the warning name. And then if we want to optimize it, turn the optimizer on, we could do this. And finally, if we want to link it with any library, you can do this. So -L and then a library name. Anyway, that is all that I wanted to show you today. I hope to make a video soon on build systems, how to compile certain projects using specific build systems, because there are multiple build systems in existence. And I want to show you how to compile a project from that if you want to learn how to build from source. I hope you learned something today, and I'll see you in the next one.